Hello, welcome to the video. In this lesson, we're going to be looking at section 2.3, where we're going to be solving inequalities using multiplication or division. Just like 2.2, where we're dealing with inequalities with addition or subtraction, same principles with multiplication or division. You are going to be doing the same exact process as if we were solving equations. Again, we're just having inequalities instead. The one thing that changes when it comes to multiplication or division is there is the possibility of having to the need to change the inequality sign with respect to what you are multiplying or dividing. Okay, so for instance, here it's talking about multiplication and division of inequalities. Both of these scenarios, we are multiplying both sides by a positive number. In this example here, when we're dealing with numbers, we're multiplying 2 to both sides. Over here, we're dividing 2 to both sides. If you notice, the original inequality is true. -6 is less than 8. I agree that is a true statement. When I multiply both sides by a positive number, it remains a true statement. Same thing goes for uh, same thing goes for the division. 6 is greater than -8. That is true. Dividing both sides by 2, 3 is greater than -4. Also true. So dividing by a positive number, keeping the inequality the same way is in fact true. But let's look at it another way. Let's say I multiplied or divided it by a negative number. So keeping that same value, let's say -6 is less than 8. But what if I multiplied both sides by a negative number? So let's say I go -1, and let's say I go -1 here as well. -1 times -6 is +6, and -1 times 8 is -8. Now, if I kept this inequality the same as less than, this would be a false statement. So in order for it to make it true, I have to flip it. So by flipping the inequality makes it a true statement. So the rule is anytime you multiply both sides of an inequality by a negative number, you must flip the inequality. So this is where that flip comes in. Same thing goes for division. I'll just use this as an example. -6 is less than 8. But now if I divide by -1, so now I get +6, I get -8. Again, I have to flip the inequality in order to make it true. So just be mindful of what you are multiplying or dividing both sides by in order to make the correct sign for your particular problem. So here, for example A, I have x over 8 is greater than -5. Because it's a division problem and I want to isolate it, I got to multiply both sides by 8. I'm multiplying both sides by a +8. So that means that my inequality stays intact. So x is all I have left on the left-hand side. I keep my greater than because it's a +8 I multiplied both sides by. And a -40 is the product of -5 times 8. Graphing this, same deal, -40 in the middle. This is now an open circle. My variables on the left-hand side, so I can identify the arrow is going towards the right, and that's how I shade that. For B, divide 3 to both sides, I'm dividing it by a positive 3. So now I have negative 8 because that's negative 24 divided by 3. I have greater than or equal to x. It's an acceptable answer, but I need to graph this, so I'm going to flip my values around with respect to the inequality. Negative 8 is where my inequality sign is open towards, so I'm going to keep that consistent when I make the change. So when I put negative 8 here in the graph, this one's a closed circle, and the shading is going towards the left side of my number line. And this is kind of a more extensive chart of what I talked about with changing the inequality. I would just suggest read it. Here it just simply says when multiplying or dividing each side of an inequality by the same negative number, the direction of the inequality must be reversed. So that's where that's coming from. So again, this is a situation where now you're either multiplying or dividing it by a negative number. So multiplying this by negative 3, this gets canceled. I got negative 6 over here. It was less than, now it's going to be turned to greater than y. So if I wanted to graph this, I'm going to put y over here. I got negative 6. Negative 6 is where the inequality is open towards. I'm going to leave it like that. Graphing that, negative 6, open circle, shades towards the left. So in this particular problem, it's asking us, it says you earn $9.50 per hour at your summer job. They want us to write and solve an inequality that represents the number of hours you need to work to buy a digital camera that costs $247. So you have this piece of information here that says that you can work $9.50 per hour. I'm going to say that is X. And the camera that you want to buy is $247. Could you have exactly that much many hours? Yes, so it could be equal to. Could you have could you work more hours and get more money in order to buy the camera? The answer is yes. So the inequality I'm planning on using is greater than or equal to in this situation. So to figure out how many hours you need, you simply divide 9.5 to both sides, and I get 247 divided by 9.5, which gives me an answer of x must be greater than or equal to 26 hours. So you must work 26 hours in order to uh, achieve enough hours to purchase that camera. Here it says you have at most $3.65 to make copies. Each copy is 25 cents. Write and solve an inequality that represents the number of copies you can make. So each copy is 25 cents, so 0.25 per copy. So we'll call that C for copy. You currently have $3.65. It says at most, so again, this is equal to, but the inequality I plan on using is less than because you can't have, if you make too many copies, you are going to go over the $3.65 limit of how much you have. So dividing 0.25 to both sides, I got 365 divided by 0.25, and I get C is less than or equal to 14.6. So they want you to solve. It says, how many copies can you make? Well, you really can't make 0.6 of a copy. So four, you can have up to 14 copies made. Last problem here. It says the maximum speed limit for a school bus is 55 miles per hour. Write and solve an inequality that represents the number of hours it takes to travel 165 miles in a school bus. So you can kind of use that the distance equals rate times time uh, formula, and they give you they give you the distance here, which is 165. They give you the rate, which is 55 miles, and they want to know the number of hours. So T is here. And with that, because it's maximum speed, we want to know it can be equal to, but it can't be any more than that. So we want to say that it's less than or equal to in this particular situation. Or if you wanted to write it where the variable was on the left-hand side right off the bat, which I'm going to do, 55 is greater than or equal to 165. So I'm going to divide 55 to both sides, which then tells me that T is greater than or equal to 3 hours. All right, and that is being able to solve inequalities using multiplication or division. Hope this helps. Till next time.